Right, good day, AP students. In celebration of, welcome back to term 2, in celebration of the fact that we're now allowed to run, we will be wearing our running shorts on our heads for this lesson. If you could just quickly go get your running shorts and put them on your head as well, in unity of this great day, it would be much appreciated. Okay, so first of all, what we're going to be looking at is we're just going to have a quick recall of what the definition of explicit and sequences as well as recursive sequences is, and then we're going to go a reminder of what arithmetic and geometric sequences are and how you interchange between explicit and recursive sequences. Okay, so the first thing is, and you can get this down, is what is an explicit sequence. So an example of an explicit sequence is Tn is equal to 3n minus 1, or the term in position in n is equal to 7 times 2 to the n minus 1. Remember, Tn is the value of an individual term, okay? N is its position in that term. So T7 is a term in position 7, and you replace n with 7. Okay, so these are explicit sequences. They're also called general formula or general sequences. And what they do is they generate the value of a term based on its position in the sequence. In many ways, they're more easy to work with manually than recursive sequences because you just need to plug in a single value. So, for example, if we told you had a sequence and the general formula for that sequence was Tn is equal to 3n minus 1, it's explicit because it's generating the value of the term based on its position. Then if I then said to you, using that formula, go find term 50, well, you'd replace n with 50, so it'd be 3 times 50 minus 1, and 3 times 50 minus 1 would be 149. Right, so those are your reminder of what an explicit sequence is. Okay, right, and then a recursive sequence, okay, it doesn't generate the value of a term based on its position, but it generates a term based on the value of the preceding term, or in other words, on the value of the two preceding terms. So in other words, if it's based on the value of just the preceding term, so in other words, you need term 3 to get term 4, or you need term 11 to get term 12. Okay, so the value of the preceding term we would call Tn minus 1. And if it depends on just the one term before, okay, on the preceding term, that's called a first order difference equation. However, if it depends on the value of two preceding terms, we haven't really done these yet, okay, that is called, in other words, you need to get term 5, you'd need term 4 and term 3. To get term 21, you'd need term 20 and term 19. In other words, in general, to get Tn, you'd need Tn minus 1 and Tn minus 2. So it depends on two terms before, hence it's called a second order difference equation. Right, get that down. Okay, let's have a look at an example of a recursive sequence, in particular a first order difference equation. So if I said to you the term in position n plus 1 is 4 times term n, in other words 4 times the term before, plus 3, n is a natural number, and t1 is equal to 5. What I want you to do is determine the sequence. Now when they say determine the sequence, we're going to write down if they ever ask you to determine the sequence, we write down the first 4 terms of that sequence, okay? And then a separate question, go find term 10. Right, so from this formula, it's apparent that term 2 would be equal to 4 times the term before, which is term 1, plus 3. Okay, so term 2 would be equal to 4 times, what's term 1? It's 5 plus 3, which is equal to 23. Right, go find term 3 and term 4. Give it a go. Press pause and do that. So, term 3 would be 4 times term 2 plus 3. So what's the value of term 2? It's 23. So it's 4 times 23 plus 3, which is 18, 92 plus 3, which is 95. Okay. And then term 4, okay, would be 4 times term 3 plus 3, which is going to be 4 times 95 plus 3. 90 times 4 is 360, plus 20 is 380, plus 3 is 383. So the sequence, okay, if you wanted to write it down, would be equal to, the first term was 5, the next term is 23, 95, 383, don't need the bracket, and then you go dot dot dot. Right. If we said go find the value of term 10, okay, well the easiest way to do it is just on your calculator. What you're going to do on your calculator is you're going to go enter the first term, which in this case is 5, then press equals, so you're going to go 5 equals, now it's stored in your memory. Then you're going to clear it, okay, and equals, then you're going to clear it, and then on your calculator, okay, you're going to go, what are we doing? 4 times answer plus 3, okay, and you're going to keep pressing that, and every time you press it you get to the next term. Right, so let's go see, let's make it a bit more, let's keep it as term 10. Okay, try it and check that you understand your calculator. Okay, I just ran to get my calculator. So on your calculator, to work this out, you're going to go 5 equals, okay, your first term, clear it, then you're going to go 4 times answer plus 3. What did I do there? 5 equals, clear it, 4 times answer plus 3 equals, and you should get the next term, which we said was 23. So that's term 2, 23, term 4, term 2 is 23, term 3 is 95, term 4 is 383. So it's working. Always check that it's working first. And we've got to get to term 10, so I'm on term 4, and 5, 6, 7, 8, 9, 10. So I got term 10 was equal to 1572863, which is 1,572,863. Okay, get all of that down. Okay, now we are having a look at certain types of sequences, and the first one we're going to look at is an arithmetic or a linear sequence. And the characteristic of an arithmetic sequence is that there's a common difference. In other words, you're adding or subtracting the same amount to get from one term to the next term. So the notation we give for that common difference is D. Okay, and the way you find D is your difference would be any term minus the term before. So D would be term 2 minus term 1, term 3 minus term 2, term 4 minus term 3, and they would all have to be the same. You have to have a common difference if the sequence is to be classified as an arithmetic or linear sequence. General notation we could use, the difference is equal to Tn minus 1, just means the value of a term minus the term before. You could also write that as term n plus 1 minus term n, saying exactly the same thing. So the first example we're going to do is you've got a sequence 11, 8, 5, and 2. Okay. The question is determine the first order difference equation and hence find term 20. Right, go give that a try. Press pause. So, what are you doing to get from one term to the next? Right, let's start with Carla. Okay, so Carla, what are you doing to get from one term to the next? You're taking away 3. Fantastic. So the term in position n plus 1, okay, is equal to the term before, which we would call term n. If term n plus 1 was a term, then the term before term n plus 1 would be the term in position n, okay, minus 3. Okay, don't forget you have to write, you couldn't generate the sequence based just on that. You have to also write down the value of the first term. So term 1 is equal to 11. Now just one little detail, okay, is if I'm working like this, what could n be? Well, we could start with n is equal to 1, okay, so because you could have term 1, okay, so, and then it's just natural numbers, so you can just write n is an element of natural numbers. you just have to choose one or the other of the ones I'm going to do. Perhaps it's easier to work with stick to one type, n plus 1 or tn, but if you did use tn, okay, then let's have Andy. Okay, what would tn be equal to? It would be equal to the term before, which in this case we'd call term n minus 1, okay, minus 3, good, and term 1 would still be equal to 11. Could we now say n is an element of natural numbers? Well, we couldn't actually, okay, because if you said n was an element of natural numbers, then this would be term 0, okay. So in that case, you probably have to say n is the first greater than or equal to 2, n is an element of natural numbers. Personally, I wouldn't penalize you if you put those down. In some cases they do though, because then you'd have the first term that you generate would be term 2, which would be term 1 minus 3, which is the same thing if we use that. I hope that makes sense. So you pick one or the other, okay, way of expressing your recursive or first order difference equation. Right, now you have to find term 20 on your calculator, okay, and let's have Nao, Grumpy Nao doing that. Okay, so Grumpy Nao, I'm joking by the way, term 20, how are we going to do that? Well, it's here, yes, you're correct. You're going to first enter the first term 1 on your calculator, so you can go 11 equals, then you're going to clear it, okay, or clear it, and then you're going to go, what are you doing to every single term? So now you're going to go answer minus 3, and then you're going to count. So if you go answer minus 3, and you do that 20 times, you should get an answer of, okay, so your final solution is term 10 is equal to negative 46. Okay. Right. Get that down. Okay, rat bags. If I'm working same sequence as we just did, 11, 8, 5, and 2, okay, which is arithmetic. And the question now says, previously we did a recursive sequence, now it says determine the general solution of the sequence and hence find term 20. So, give that a go. Done them before. Press pause and try it. Right, so there are two ways we can get the general formula for an arithmetic sequence. Okay. And the first one, Kai, is by inspection. So how do you do it by inspection? Well, you say, what am I doing to get from one term to the next? In other words, what's my common difference? Well, I'm taking away 3, so my difference is negative 3. So in this method with inspection, you're going to go term n is equal to dn, so always going to be the difference times n, plus, and the way I think about it is that you balance according to t1. Okay, what the hell am I talking about? Well, your difference is negative 3, okay, so it's going to be negative 3n. Now, if I balance according to term 1, the moment term 1 would be negative 3. But what should it be? It should be equal to 11. So what I have to do to negative 3 to get to 11, I have to add to 14. So your general sequence is term n is equal to negative 3n plus 14. So that's one way you can find a general formula for an arithmetic sequence. The other way is to use a formula. And Jasmine, if I use a formula, you can go learn this off by heart. This is a formula for any arithmetic sequence in explicit form, and that's term n is equal to a plus n minus 1d. In this notation, a stands for the value of the first term, d is the difference. So, Jasmine, what is a? Good. A is equal to 11. And what is your difference? Your difference is negative 3. So now it's just a case of subbing into that formula. Okay, and you're going to get term n is equal to 11 plus n minus 1 times negative 3. And if you simplify that, you get term n is equal to 11 minus 3n plus 3. So term n is equal to negative 3n plus 14. Well done, Jasmine. And that's fantastic news, because you got the same answer as that over there. So either way, it doesn't matter. Okay, you can either do any arithmetic sequence by inspection, or by using the formula. So we got to a solution of term n is equal to negative 3n plus 14. And now the question is, go work out the value of term 20. So that's pretty easy. So we'll give it to ratbag. And so term n is minus 3n plus 14. So ratbag, what is it going to be? Good. It's minus 3 times 20 plus 14. And as we said, if she can get that right, pretty much anyone can. So I get minus 60 plus 14. And minus 60 plus 14 is negative 46. Which is, if you go back and have a look at when we did this by recursive formula, that is also the solution we got using a recursive formula. So well done, ratbag, and remember, I am only joking. Sort of. Okay, a lot of you have been struggling to get things down, so here's a nice, you can press pause and you can get everything down. Hopefully it is clear and lovely. Okay, so the next kind of sequence, we looked at arithmetic sequences, and in arithmetic sequences there was a common difference. In geometric sequences, there's a common ratio. In other words, you're multiplying by a constant number to get from one term to the next. The other name for geometric sequences is exponential sequences, and the reason why is if you plotted a graph of n against Tn, well, it would look like this, like an exponential graph. That is, if your ratio is bigger than 1, and if your ratio lies between 0 and 1, it would do that. Anyway, don't worry about that. If you can't see that or get that down, it's not the end of the world. So to find your common ratio R, well, if it is a geometric sequence, the following will happen. Term 2 divided by term 1 will be equal to term 3 divided by term 2, which is equal to term 4 over term 3. In other words, in general, your ratio is the term in position n plus 1 divided by the term before, which in that case would be term n, or you could say it's equal to the term in position n divided by the term before, which would then be Tn minus 1. And the first example, which I want Julia to do, is if you've got 5, 20, 80, 320. Okay? The question is, determine the recursive formula for this sequence, and hence find term 15. Right, press pause and give that a go. So, Julia, what are you doing to get from one term to the next? That's correct. You're timesing by your ratio. Okay, in this particular sum is equal to 4, because if you go 320 divided by 80, you get 4. If you go to 80 divided by 20, you get 4. If you go 20 divided by 5, you get 4. So you're multiplying by 4 in each case. So your ratio is equal to 4. So in other words, to get from one term to the next, term n plus 1, okay, would be equal to 4 times the term before. And if we're talking about term n plus 1, the term before would be Tn. And then you've got to write the value of the first term, and the value of the first term is 5. So you'd have to write both of those things. You get a mark for that and a mark for that, okay, in that particular case. So term n plus 1 is equal to 4 times term n, and term 1 is equal to 5. Likewise, you could say term n is equal to 4 times term n minus 1, okay, and term 1 is equal to 5. Okay, right, so that is your recursive formula. The question then says go find the value of term 15. So what are you going to do on your calculator? Okay, so on your calculator, you're going to go put the first value of the first term in. So you're going to go 5 equals, puts it into your memory, clear it up, okay, and then you're going to go 4 times, and then you use your answer button repeatedly, okay, and if you do that, you should get an answer of, what did you get, Julia? Indeed, you are correct. You should get massive number 1, 3, 4, 2, 1, 7, 7, 2, 8, 0. Okay, so geometric common ratio, how do you find it? That's the procedure for finding your common ratio, and then you're just going to say your ratio times term n minus 1. If you're working with recursive, don't forget to write down the value of your first term, and make sure you know how to use your calculator and the answer button to generate that. Okay, press pause, get everything down. Okay, right. So we're going to now, the next question, we're going to work with the same sequence, 5, 20, 80, 320, And instead of asking you for a recursive or a first order difference equation, we're going to ask you for an explicit formula or the general term, and hence determine term 15. Right, do you want to pause and try it yourself? Okay. So first of all, you've got to check, is it a geometric sequence? We wouldn't tell you. Well, to find is there a common ratio, if you can't see it, well, if you went term 2 divided by term 1, you get 20 over 5, which is 4, which is equal to 80 over 20, which is 4, which is equal to 320 over 80, which is 4. So there is a common ratio, and that is equal to 4. There's a different notation we're going to use, and sometimes they refer to the common ratio in AP, in sequences section, as K. So K would be the same thing. K is just your common ratio, which is 4. The notation A is the first term, so A is equal to 5. And sometimes, as I say, this is just in AP modeling. We sometimes use this language. Okay, that we always use in core and in AP as well. Okay, but it's saying the same thing. Okay, so T1 is equal to 5. So if you're using this notation, then we'd say Tn is equal to AR to the n minus 1. So your general formula would be Tn is equal to 5 times 4 to the n minus 1. And that would be your answer. And if you use this notation, then the general formula is Tn is equal to, this is for geometric, remember, those two formulas are your formulas for geometric. Okay, and term n would be equal to term 1 times k to the n minus 1, so term n would be equal to 5 times 4 to the n minus 1. Remember, you can't times those two together because they don't have the exponent. So either way, it doesn't matter which notation you use, your general formula or your explicit formula is 5 times 4 to the n minus 1. Right, so now Sarah, go work out the value of term 15 for me. Okay, and if you work out the value of term, yes, that is right. Okay, so you're going to go 5 times 4. Sarah magnificently does this. She replaces n with 15 in a moment of genius. And in your calculator, you're going to go 5 times 4 to the 14. And if you enter that, you get the same answer as we got for the recursive when we did that same sum with recursive formula as 1, 3, 4, 2, 1, 7, 7, 2, 8, 0. Sarah, high five yourself and go get yourself a drink. Right, get that down, press pause, copy it down. Okay, right, so the next example, okay, is you've got 200, 216, 233,28, 251,9424. 200, 216, 233,28, 251,9424. That's our sequence over there. Okay, and the question says determine the first order difference equation and hence determine term 18. Right, press pause and get that down. 200, 216, 233,28, 251,9424. That's the sequence. Right. Well, the first thing you're going to have to figure out, and you, Sarah, is doing the sum with us, and is it arithmetic or geometric? Okay, or neither. Well, first of all, let's check if it's arithmetic. Well, to get from there to there, you're adding 16. If it's arithmetic, I'd have to add 16 to get to the next one, and you don't, because it's 233, not 232. So it's definitely not arithmetic. What about geometric? Well, to test if it's geometric, let's look at our ratio. So on your calculator, go 216 divided by 200. Okay, so 233,28 divided by the term before, which is 216, and 251,9424 divided by 233,28. Okay, and you should, okay, go check what it is, work out all three of those, and if you haven't made a careless mistake, you get an answer, a common ratio of 1,08. And if there's a common ratio, it's telling us that it's a geometric sequence. Right? So you're timesing by 1,08 to get from one term to the next. Right, so now you should be able to find the first order difference equation and hence determine, remember, first order difference equation is a recursive formula. So go do that and then go find term 18. Right, so Sarah, what did you say? And indeed you are correct. The formula, the first order difference equation, will be term n plus 1 is equal to 1,08 times the term before, which would be term n. You could also write it as term n is 1,08 term n minus 1. And in both cases, you have to also write down the value of the first term, which is that T1 is equal to T100. Right. So, term 1 is equal to 200, and there is the formula you're going to work with. Okay, well done, Sarah. And now you have to work out, which Francis is going to do for us, the value of the term in position 18. So on your calculator, you put in the first term, which is 200, press equals, clear it, okay, and then you're going to go answer times 1,08, and then you're going to count. Well, first of all, check you're getting the right answers. Okay, check you're getting, the next one should be, to your first one you should be 216, then you should get, if you're not getting those, you've made a mistake in entering this information. Okay, and you should end up with an answer for term 18 of being equal to 740. Okay. Alright. Now just one thing. What you're actually doing here is you're timesing by 1,08 to get from one term to the next. Right? And if you're doing that, if you're timesing by 1,08, is what you're doing is you're increasing by 8%. Okay, if you're increasing by 8%, you'll times by 1,08. If you're increasing by 12%, it'll be 1,12. 20%, 1,2. 4%, 1,04. Right? So we're going to get to this at a later stage when we work with annuities, with finance. So timesing by 1,08 has the same effect as applying an interest rate of 8%. So if you had 200 Rand in your bank account, okay, and you applied 8%, the next year you'd have 216 Rand. If it's compound interest, in other words, you're applying interest to the year before. If you apply 8% interest to that, you get 233 Rand and 28 cents, 251 Rand, okay, etc. So, just one thing you've got to be careful of, T18, okay, wouldn't be the amount that you had after 18 years, it would be the amount that you had after 17 years, because if you're working in finance, okay, so if you're working in financial language, we say that the first term is T0, okay, which would be equal to 200, okay, which here we say the first term is term 1. I don't want you to get too stressed about this if you're not getting this now. So after 1 year, okay, T1 would be 216 in financial notation, okay, whereas in sequence notation, so in sequence notation, okay, let me actually just explain this to you on a separate board. Just get what you've got there down for them. Alright, so just make sure you've got that down. Okay, that's all you really have to worry about for now. Right, the last example was example pig. This example, if you can go back and check, the difference now is we've got example pig with a belly button. Okay, and you've got 200, 216, 233,28, 251,924. Right? So we know from the previous question that it's geometric, okay, and we know that your ratio is, to get from one term to the next, you're timesing by 1,08, which we said was the same effect as increasing by 8%. Increase something by 8%, you're timesing by 1,08. And the question now, though, last time we did a recursive formula or a first order difference equation. Now we want the general solution or the explicit sequence, okay, and hence find term 18. Right, go for it. Okay, remember you're going to either use term n is equal to AR to the n minus 1, or you're going to use term n is equal to term 1 times k to the n minus 1. They're saying exactly the same thing. Here we talk about R in that notation they talk about k. And we know that r is 1,08, or you can use k as 1,08. It's just a different language for saying the same thing. Right, press pause, try that, check that for term 18, you get the same answer as last time. You should have got an answer of 740. Pause, stop it, and give it a go. Right, so if I substitute my values in, I get term n is equal to a, which is 200, or term 1, times r, which is 1,08, okay, to the n minus 1. So that is your explicit sequence, or your general solution. Okay, and then the next part of the question is go find term 18. So term 18 will be 200, 1,08 to the n minus 1 to the 17. And if you put that into your calculator, you get, voila, the same answer. Who was doing this for us? I think Yasera. Well done, Yasera. High five yourself. You get an answer of 740. Okay. Right. Copy that, get that down. Okay, I'm just trying to, in this next little bit, try to link up this sequences to finance, because the way we teach maths is that you think they're completely unrelated, these different sections of maths, but they're actually very closely related. Finance maths actually depends on sequence notation to a large degree. So this question, which we asked as a sequence question, 200, 216, 233, and we ask you to find the value of T18. We could also have asked that as a financial maths question, and if you don't quite get all of this now, don't stress about it, we're going to go back to it. Where we could have said, if you applied 8% compound interest per annum to an emission amount of 200 Rand for 17 years, how much money would you end up with? Okay, so, and it would be the same, effectively the same question, because if you applied 8% interest, after 1 year you'd have 216, 2 years 233,28. Okay, but why, okay, is it 17 years? That's what I'm looking at. And the thing to remember is in sequence notation, we refer to the first term as being term 1. Okay, so term 1 is the starting point. So after 1 year, okay, if you applied 8% interest, in other words, you times by 1,08, that's 8% interest, times by 1,08. After 1 year, you'd have 216 Rand. If you then times that by 1,08, because it's compound interest you applied to the year before, to the interest previously earned, you'd have 233,08. So remember, timesing by 1,08 is applying interest of 8% for the year. Okay. So T2 would be how much money you had after 1 year. Term 3 would be how much money you had after 2 years. So T18, okay, in sequence notation would be how much money you had after 17 years. And that's why when we work out Tn, it's 200. If you use that formula, AR to the n minus 1, then that your first term is T1. Okay, so term 18 would be 200 times 1,08 to the 17. Okay, right. So press pause. If you want to get that down, as I say, if you don't quite get this link up with finance, it's really not the end of the world. Right, now just to link it up, what we're doing with finance notation, in sequence notation, the first term we used was term 1. In finance notation, the first term is T0. So if I invested 200 Rand for 17 years at 8% per annum, this would be your number line. We'd call in finance, okay, the first term we'd call T0. In sequences, it was term 1. So you'd have 200 Rand, you'd apply 8%, you'd have 216 Rand. It's compound, so you apply the 8% to the accumulated amount, which is 233 Rand, okay, and you end up with 740 Rand. Okay, but this in finance notation is T17. Remember, in sequence notation, this was T1, this was T2, this was T3. T1, T2, 3. That's what we use in sequence notation, where that would be in finance notation, T0, T1, T2. That's why in sequence notation, okay, this over here was T18. So to work out the amount of the 17 years of investment, you'd still be working out T18, and you'd use AR to the n minus 1, which would be AR to the 17 in your geometric formula. In finance, the first term is T0. I don't know whether you should have done this in grade 9 even, never mind this year. and if you're applying compound interest, A is P1 plus I to the N. Okay, P is your initial amount which you invested, which is 200. 1 plus interest rate is 8%, which is 0.08 to the 17. So you end up with the same thing. Here, to work out T18, you would have had an initial amount A of 200. Your ratio is 1,8 to the 17. Okay, so 200 times 1,08 to the 17 was your answer. And in compound interest formula, okay, P 200 1,08 to the 17 is also your answer. But just remember that subtle difference. Okay, in sequence notation, 17 years of investment would be called T18. Here would be like that. If you didn't get all of this stuff, linking it to finance, it's fine. We're going to do it again. Just an introduction to the concept. Okay, right, get that down. Okay, we're getting there. Right, next example chicken. Okay. Right, determine the general solution of the following. Okay, so if we gave you term n plus 1 is equal to term n minus 11. Okay, so they've given you a recursive formula, and they want you to write the general solution of this. In other words, get the explicit formula of that. Okay, so to do this, you'd say, well, what are you doing to get from one term to the next? We can't generate the sequence because we don't know the value of any terms. Okay, but we know that the difference is negative 11. Okay, to get from one term to the next, you're taking away 11. So I would recommend in this case, so if you're taking away 11, what kind of sequence to get from one term to the next? That tells us we're working with an arithmetic sequence. And if you work with an arithmetic sequence, then that's your general formula. Term n is equal to A plus term n minus 1D. So the best we can do, if this is all the information that you're given, is to say that the term in position n will be equal to A, in other words, term 1, plus n minus 1 times by your difference, make sure it's in a bracket, which is negative 11. Okay, if you want, you can neaten it up, but it's quite acceptable to leave it like that. So that is your answer. That's the general solution. That's the best we can do. Term n is equal to T1 plus n minus 1 times negative 11. Okay, if that's the information that we given. Okay, get that down.